So here is another question on simple harmonic motion, energy of simple harmonic motion. So it is given that a curve depicting variation of potential energy versus position. Okay, it is given below. The mass of the body is 4 kg. It is vibrating in SHM. From this, we have to calculate the time period of oscillation of the body. Okay, so this is potential energy versus position, instantaneous position. So the standard SHM equation is x is equal to a sine omega t plus phi, but here initial phase angle information is starting from 0, so it is a sine omega t. Here from this graph, two things are clear. First is that the peak amplitude, the maximum displacement from the equilibrium position, that is A, is equal to 0.2 meters. Okay, this, and that the maximum potential energy of this object is 1 joule. So another thing which you must understand is that maximum potential energy happens when the value of kinetic energy is 0, because sum of potential energy and the kinetic energy, it is constant throughout, that is the total energy is constant. So in a way we can also take this as the total energy, okay, at x is equal to 0.2 meter at the peak amplitude. Okay, that. So here from this we will calculate some values which are required for calculating the time period. So first is total energy is given as 1/2 k a square, which is 1 joule here. That implies 1/2 k, substitute a with 0.2 whole square is equal to 1 joule. That implies k is equal to 2 by 0.2 whole square, that is equal to 50 Newton per meter. That is the value of the force constant K. Okay. Then we know that the angular frequency omega is equal to root over of K by M. Okay, this mass of the body is equal to 4 kg, it is given. So from here we will calculate the angular frequency, that is 50 by 4. So it is coming around, so it will be 25 by 2 if we cancel it, this 5 by root 2, so it will be, let's calculate, 3.53 radians per second it is coming. Okay, angular frequency is 3.53 radians per second. Then we know that angular frequency is equal to 2 pi by capital T, where capital T is the time period. That implies time period T is equal to 2 pi by omega, which is equal to 2 pi by 3.53 radians per second, and that is equal to, it is coming around 1.78 seconds. Okay, the time period is 1.78 seconds. This is what it was given, it was asked in the question to calculate. Okay, so this is the thing. So here is another question on energy of simple harmonic motion. So it is given that the total energy of a particle executing simple harmonic motion of period 2 pi seconds is 1.024 into 10 to the power minus 3 joules. The displacement of the particle at pi by 4 seconds is 0.08 root 2 meter. Calculate the amplitude of motion and the mass of the particle. Okay, so here we have to calculate the amplitude of the SHM motion and the mass of the object or the particle undergoing SHM. So first we have to write the basic displacement equation of simple harmonic motion, okay, where y is the instantaneous position or displacement. Here we have given that the time period t is equal to 2 pi seconds. Okay, so angular frequency we can calculate, it will be 2 pi by time period, which is equal to 2 pi by 2 pi, which is equal to 1 radians per second. Okay, 1 radian per second, that is the angular frequency. Then it is given that the displacement of the particle at t is equal to pi by 4 seconds. At t is equal to pi by 4 seconds, y is equal to 0.08 root 2 meter. That implies if we substitute this value here, it will be equal to, that implies 0.08 root 2 is equal to a sine omega, which is equal to 1 into pi by 4. Okay, this because omega we have calculated, it is 1 radian per second and t is equal to pi by 4 seconds. That implies a is equal to 0.08 root 2 by sine pi by 4. This is coming equal to 1 by root 2. It will be 1 by root 2, it will come in the numerator, root 2 into root 2. So it is 0.16 meters. Okay, the amplitude of the SHM motion equal to 0.16 meter. This is the amplitude. The first part of the question we have done. Now it is given that the total energy ET is equal to 1.024 into 10 to the power minus 3 joules. We know that for SHM motion, this total energy is equal to 1 by 2 K A square. This we have already calculated A, so we'll simply substitute the value here. That implies 1 by 2 K into 0.16 whole square is equal to 1.024 into 10 to the power minus 3 joules. From this we can calculate the force constant K, which is equal to 2 into 1.024 into 10 to the power minus 3 by 0.16 whole square. So it is coming around 0.08 Newton per meter. Okay, this is the value of force constant. Now we also know that the angular frequency omega is equal to root over of K by M. Okay, that implies omega square is equal to K by M that implies mass m is equal to k by omega square. So here it will be equal to 0.08 Newton per meter, which is the value of k, and angular frequency omega, which is equal to 1 radian per second, which you have calculated already. So 1 square. So that is equal to, the mass is equal to 0.08 kg. So the mass is equal to 0.08 kg. This. Okay, so this is the first part of the question which we calculated, the amplitude, and this is the second part of the question, that is the mass. So the most important thing in all of these questions is to remember the formulas of the different parameters and how to manipulate the basic displacement equation, this, into various forms. Whether you have to calculate any SHM parameter, be it acceleration, velocity, maximum velocity, force constant, angular frequency, amplitude, whatever you have to calculate, all is there in this basic format of displacement equation. Basic manipulation of this equation gives us all the results. Okay, so the important thing here is to first remember all the formulas and then how to use them to determine the various parameters. Okay, so here is another question on energy of simple harmonic motion. So it is given that a particle which is attached to a spring oscillates horizontally with simple harmonic motion with a frequency of 1 by pi hertz and a total energy of 10 joules. If the maximum speed of the particle is 0.4 meter per second, then what is the force constant of the spring and the maximum potential energy during this whole SHM motion? Okay, so first, horizontal SHM motion. So basic displacement equation will be x is equal to a sine omega t. A amplitude, omega angular frequency, t is particular time instant, x is instantaneous displacement along the horizontal axis. Here it is given that frequency f is equal to 1 by pi hertz or second inverse, this. So from this we can calculate the angular frequency omega, which is equal to 2 pi f, which is equal to 2 pi into 1 by pi, which is equal to how much? 2 radians per second. Omega is equal to 2 radian per second. That is the angular frequency. Then it is given that the maximum speed or maximum velocity is equal to 0.4 meter per second. We know maximum velocity in SHM is equal to omega a. Here a we have to determine it. Okay, omega we have calculated 2 radians per second. So that implies 2a is equal to 0.4 meters per second. That implies a is equal to 0.2 meters. That is the amplitude of SHM. Okay, the amplitude of SHM. Then it is given that the total energy ET is equal to how much? 10 joules. Okay, 10 joules. We know total energy in SHM is given by 1 by 2 K A square. A we already know, 0.2 meter. Total energy we know. So that implies 10 is equal to 1 by 2 K into 0.2 whole square. That implies K is equal to 10 into 2 by 0.2 whole square. That is equal to how much? It is coming around 500 Newton per meter. That is the force constant or the spring constant. K is equal to 500 Newton per meter. Then it is asked to find the maximum potential energy. So as we have already discussed in the previous questions, the sum of kinetic energy and potential energy, that is always constant throughout the SHM motion. The kinetic energy is given by 1 by 2 K A square minus Y square, and the potential energy is given by 1 by 2 K Y square, and the total energy expression is equal to 1 by 2 K A square. So when the particle reaches the maximum amplitude position, okay, when the particle reaches the maximum amplitude position, the potential energy is equal to 1 by 2 Ka square at y is equal to A, the maximum amplitude position. And at that position, the kinetic energy is equal to 0 joules at the extreme points of SHM motion on either side. So here the maximum potential energy EP max, that is equal to the total energy ET, which is equal to 10 joule, and at that point the kinetic energy is minimum, that is equal to 0 joule. The sum of potential energy and kinetic energy throughout the SHM motion is always constant. We have already discussed it in the energy in SHM video, where we have derived the mathematical expression and the graphical analysis we have done, so you can check out that video. But this is the thing. So the maximum potential energy in this case is 10 joule, the total energy, okay, at the maximum the amplitude, the extreme position, where y is equal to the amplitude of SHM motion. Okay, so this is the So friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.